Hello, it's David. This is the desktop of my Mega ST that you saw me tidy up a little while ago, and I am controlling the mouse pointer here with this modern USB mouse. Now, I've shown in the past my Smalliermouse2 project, which is a fork of the excellent Smallymouse project, or Smallymouse2 project, originally conceived for the BBC Micro and various other 8-bit machines, but it also works rather nicely on the 16-bit series, and I added some features that make it, I hope, one of the better USB to quadrature mouse encoders for the ST. So here it is, fitted into the back of the Mega ST's keyboard. You can see it's quite a small thing. It's designed to fit under the ST FM STE's keyboard. Fits in the little recess on the bottom of that for the mouse and the joystick there, and it works very well, and I'm very happy with it. I have two of these, however, and this one does work, but unfortunately this one does not. And I think I have unfortunately blown up the Atmel 8090 USB 1287 chip, probably by just not handling it very gently at some point. So I think it's time for me to have a go at getting that chip off and fitting a replacement. I do have some proper parts here. Well, before we go much further, I think it would probably make sense for me to get rid of this penciled on cross on the working machine, and perhaps replace that with a tick on the working device, because that could be confusing later on. This one is the one that I believe not to be working, but I think we should probably, sorry, that's wobbling the camera like no one's business. I think we should probably test that as well. Okay, so there we go. We've got our cross version mounted in the keyboard here. We've got the desktop up, but wiggling my fingers around on the mouse, no joy. Okay, I'm afraid it's going to get noisy for a little bit here because we've got the hot air station warming up, and this is not a particularly easy evolution to take off a QFP chip here, which is basically 3/4 the size of the board. I'm going to be heating up in effect the entire board, and could be starting to make a mess of some of the components on either side, to be honest. So I've absolutely cocooned everything else as best I can in some Kapton tape, and I'm going to hold this. It's quite loosely held. I hope it's going to be tight enough, to be honest. Held this in a PCB board holder here at an angle, and all I'm going to do is to try and warm this up, and then just apply a little nudge at the top here with the tweezers, and just hope that we can flip it down and let gravity do the work. So whilst the old heat station there is getting going, let's apply a liberal amount of flux, and this is a messy affair, I'm going to be honest with you. And we will set our air gun here for 380 I'm going with, and I'm going to go to almost full airflow, not quite full, but almost full airflow, and let's give it a go. Now, I think when I've done this in the past, gosh, that flux is dripping everywhere. When I've done this in the past, this can take several minutes on a QFP 144 or something like that, whereas this is a little bit of a smaller package, and I'm hoping this should be quite quick. It's not the worst density package I've ever worked with. So we're going to just try and spread the heat around a bit. I can see a little bit of the legs sort of go a bit shiny as the solder melts. Oh yeah, starting to move. Nearly had it. There we go. Come on, gravity. There we are. And we're smoking. That's the flux, by the way. It was quite an aggressive amount of flux. Oh, my extractor can't possibly cope with that, I'm afraid. Right, now that's going to be rather toasty. So before I go lunatic in there spraying it with the old IPA, I'm going to let that cool down a bit, I think. And yeah, the same goes for the chip here, which has just glued itself now to my disc with flux. I'll let that cool down a bit, and then we'll clean it up. We'll mark that one as likely dodgy, and we'll look to get the new one on there. It's time once again for me to mention my friends at PCBWay. Not only are they the one-stop shop for your prototype PCB manufacturing needs, but they also offer CNC machining, sheet metal fabrication, 3D printing, and even injection moulding, all with an easy-to-use web interface. They have a module store, and they host shared community projects too. You can find some of my designs available for download or turnkey manufacture here, for example. Frequently you'll find discounts or vouchers or competitions being run, so if there's really anything you need in the maker realm, why not add PCBWay to your list of potential suppliers? So many thanks to PCBWay, and let's get back to the business in hand. Okay, so let's have a look at the packaging for the 8090 USB 1287. This is quite nice. There's some absolutely ludicrous packaging that goes into these chips sometimes. I've thrown away some of the boxes, but just if you buy a single CPLD, the XC95 series from somewhere like Farnell, they will ship an enormous box. I mean, it's not going to, can't even fit it on here. Huge, great thing with one little tiny chip in it. Whole load of plastic, whole load of cardboard. Ooh, fancy pantsy. There we go. Don't they look lovely? Right. Now my chip has, or my board I should say, this would have been designed using the old KiCad 6 software, and that's mechanism for identifying pin 1 was a little bit subtle. I think they've changed it now. It's this long white line just underneath the mouse logo here. You see, that's a corner, that's a corner, that's a corner, that's a corner with an extension on it. So that's pin 1. And on these, confusingly, on these chips, you've got two marks. You've got a round dot up there and a round dot down there, but it's the small round dot, I believe, that is pin 1, and that is just like a moulding impression. But isn't that annoying that they end up with two marks in opposite corners that are in fact unrelated? Right, so I think the first thing we'll do is we need to get the old solder off of that to make life a bit easier for us. Now why, you may ask, am I trying to remove this solder when I'm just about to put more solder back on? Well, the reason is to make it flat. I've had a go in the past. By the way, if there's a bit of a ticking in the background, I'm sorry about that, that's actually the fume extractor. I've had to bring it closer because I'm right down in the weeds now. But yeah, I've tried in the past to remelt solder, or actual not second, well, it's no, not second-hand solder, not where I've removed an item before, but where, for example, the manufacturing process has laid down solder paste and reflowed on boards that I've had manufactured. Then I've tried to simply sit my chip on top of those and melt them with hot air, and it doesn't. I've not been able to do it. It doesn't go well. My preferred method, therefore, is to take it back as if the board were completely virgin, and we have a completely flat, solder-free surface, and then we introduce our chip, anchor the corners, and drag the solder down the legs. Look at all that goo. Obviously better to There we go, nice squeak. Better to solder to a squeaky clean surface, in my opinion. If you're doing something like BGA soldering, you don't really have a choice, because obviously you can't get a soldering iron in there, but with QFP it's certainly doable. There we go. Now the following bit is the hardest bit to get on camera, which is where we try and line the legs up. These are relatively fine pitch. I think they might be 0.5 millimeter. No, maybe they're not 1.27, are they? I can't remember now. They may be 0.5 millimeter. They're relatively fine pitch. They're not the worst, but they are pretty tight. And you can see that even me just turning that around there has slid it along a bit. Yeah, I think sometimes this is just best to do with fingers. And really you need to be completely top down square on it, but then I'll totally block you. Right, so I'm going to keep finger pressure. I think that's okay. Oh, you can't see a thing. I think that's okay. And what I'm going to try and do is keep a bit of finger pressure on it. Can I do so in a way where you can see anything at all? Maybe you can just make out what I'm doing here. And then we'll put a blob of flux in the corner there. This is where I realise the solder's on the wrong side of my body. And this is my SMD technique here. So we've got a, I believe these are called K-tips, at least that's how I've heard them referred to previously. There's a great big angled wedge. It gives you a nice lot of area, and all I'm going to do is I'm going to melt a blob of solder, quite a respectably healthy blob of solder to start with. I don't know if that's going to focus. Yeah, there you go. That's obviously far too much solder to really do the soldering, but for the purposes of anchoring one point, that's what I want, because it's got to make sure we flow. And we try and contact the pad and the leg simultaneously. There we go. I think that has done it. It's bridged the pins, but that's absolutely fine. We're not interested in soldering for electrical connections at this point. We're interested in stopping it moving. And then we'll come around to the opposite side, double check our alignment, and we'll repeat the process. That side there doesn't look too bad now. Get it to focus properly. That doesn't look too bad. The first side, adequate. Yep. That side slightly off to the left as you look. But this one, oh no, maybe it's not too bad. It's that third side there that is not quite perfect. I think that is sufficiently off that I might try and just apply a little bit of correction, but it's going to be quite awkward to do, especially on camera, possibly impossible on camera. So I'm going to try remelting this leg up in here, because I think it's this corner, and then I'll just see if it'll just squeeze a little bit. There, maybe. How does that look? Well, I'm going to say that solved the problem at that end. That's okay. But I think it's made this side worse. But I don't see any possibility of shorts there. I think this is probably okay to continue now. Yep, I'm happy enough with that, and I've moved you around a little bit, so let's see whether you can actually see what I'm getting on with here. So, nice little run of flux, excessive amount, better to be excessive than a little bit frugal, and you really don't want very much solder on here at all. Let's start with that. That looks like a fairly paltry amount, but we'll see how far it goes. Better to be solder light and flux heavy, in my opinion. So soldering iron set for 290 with this K-tip, and away we go. I'm going to try and make impact with the pad and the leg, and we'll just work our way down and go over it many times as we want until we're happy. And there we are. That's my little tiny blob of solder has done probably 3/4 of that run. Then I go down on the top of the legs just to make sure we've got a good solder bond. And what doesn't help is the flux. It does make it hard to see what's going on, so you do need to then pick it up and inspect it from all angles and see whether you're happy with the work done. That to me looks pretty good. Rinse and repeat. Now the most obvious thing that could go wrong with this is that you simply apply too much solder and you end up with a bridge. So that's really what I'm checking for here. And it can kind of show itself as looking like almost the liquid between the legs or hidden behind the legs. Haven't seen one yet. Doesn't mean it's not there. And if you really were being particularly belt and braces, you would then go around afterwards with the multimeter and buzz out for continuity, make sure there's no adjacent continuity that that isn't meant to be there. Occasionally you have, for example, two ground legs next to each other, so you will see some legs buzz out probably. A little bit of a dry one there. Perhaps I've been a bit too stingy in my solder on this aisle. Oh, and there we go. We've got ourselves. Just as I said that, of course I've overdone it, and we do have a bridge on this particular one. It's up at this top corner. Oh, of course that was the anchor point, wasn't it? So all you do is you clean off your iron with the sponge and the wire wool. And normally that's enough to just go over it once or twice, sort of drag out as if you're smoothing down your duvet cover. Yeah, and this one's very difficult to see actually because the side is particularly shiny, so really will need to be inspected properly after we have cleaned off the flux. Goes without saying, you obviously clean your soldering iron tip every single time. And this is kind of the speed that we're talking about. And the reason why this drag soldering method is so effective with SMD components is that they don't need much solder. That little blob right at the start has done that entire row. If you were doing through hole, you would simply have to stop to inject more solder. It simply, you couldn't carry enough on the tip by itself. Okay, so my pre-clean visual inspection does reveal this sort of this side here to be my area of most concern, but we'll give it a lovely good scrubbing and we'll see what it looks like when it's all nice and dry. Well, just been doing my clean up here, and there's a couple of things to note. Firstly, I'm not quite sure that the solder has flowed properly on some of the joints along the top here. Yeah, you see it doesn't look quite right somewhere around there. I don't see any bridges on the sides that we were concerned about. I think that all looks pretty good. But having made a big play previously about where the pin 1 marker is and the 2 dots being, oh dear. Okay. Well, you've seen me desolder one of these already, so at least I don't have to record that, do I? Okay, there we go. One embarrassing correction later. What do we think? I think they look pretty good. And pin 1 marking, pin 1 dot. Oh gosh, all of those lovely bright white letters have gone, haven't they? Now it just looks like a crusty old chip again. Actually, that is a little surprising, thinking about it. I mean, that's... Is that just the heat? You wouldn't expect IPA to strip the markings off a genuine chip, would you? I mean, this is from a proper supplier, but that's a little bit strange, isn't it? Shall I give that a quick rub? Actress, bishop, etc. Must just be the heat. So there we go, that's been resoldered, hopefully with pin 1 in the right place now, and I think the job is pretty reasonable. Good. Now, when these are being programmed, I think, if memory serves, that's the bootloader setting there. But you have to issue a reset, which is to tie that pad to ground. What I normally do is solder a little line on there and just touch it to the USB here when connecting it, and that puts it into bootloader mode. But I don't think we have to bother with that when it's a brand new chip and it's blank. I think when we just plug it in, it goes into bootloader mode straight away. So I've got to try and figure out how to program this up now. Now, what I do remember is that you need Atmel Studio, which is a Windows-only application. It's based on Visual Studio. So this is quite problematic because I don't have a Windows machine here. So this is a remote Windows machine. I've got Atmel Studio all loaded up here. I think this is the last time I programmed it. This is all on GitHub, of course. Please select a connected tool interface and try again. Okay, so that was me trying to... I pressed play there, and I think that was it, trying to program it. So obviously nothing's connected yet. What you need is a USB-A to USB-A cable. And what we're going to do is to try and send the USB commands over the network using a program called Virtual Here. Now, this is running a trial mode at the moment, which only allows one connection at a time. I do have a license for it for my Raspberry Pi, but I'm going to just try to do everything on the laptop for today. So I've got the server running on the laptop OS itself. This is the client. It's picked up the OS 10. That's the official terminology, isn't it? Hub. I think it's OS 14 actually. But anyway, let's pick that up. So that's good. So let's connect up my adapter here. We'll pop that into the laptop, and I'm going to plug this in and we'll see if we get any. There we go. So it's picked up the network card. It's also picked up an 1890 USB 128 DFU. 1890 USB 128 DFU. DFU, I was expecting that to say something like bootloader or something like that, but anyway, we'll see. That might be the correct thing. So to be fair, it may not be compatible. There's a lot of cleverness that goes on when you attach one of these things. They sometimes change their IDs and all sorts of things going on, so it may not work with the remote virtual USB, but we'll give it a try. Right, so I'm going to try now. Yeah, nothing's showing up there. Please select a connected tool. Okay, I went away and had a little think, and I looked up what the DFU meant, and that is the device firmware upgrade. So that is actually already correct. And I'd forgotten how this virtual here hub works. Basically, you have to choose what you want to connect. The trial version allows you only to connect one thing, so you have to choose which one it is. I'm a fool. So let's try that again and see whether it works. And if it doesn't work, we'll try the Linux hub, because, to be honest, the compatibility is better in general. So we're going to connect this up again. 1890 USB 128 DFU appears there on my list. And what I'm going to do is click on it this time, which may help. In use by me. There we go. So let's try that again. So now it is actually attached to this machine, and there we go, straight away. Oh, I'm a fool. Right, there we go. Atmel DFU 1.00. There it is, set up nicely. So there's our chip connected there. Tools, device programming. There we go. Aha, there we go. This looks familiar. Atmel Mega DFU 1287. Apply. Read the status back. There we go. We've got a number, so that's good. Reading device was okay. I'd quite like to program it, please. How do I do that now? No. Here we go. Right. So, presumably that's my program file. Let's verify flash after programming. Sure, why not? Let's go program. Programming flash, verifying flash, okay, there we go. That was it. I really should have paid a bit more attention on that video, hadn't I? Okay, so let's pop our USB remote dongle in there. We'll try and slot this. Which way around does it go? I can't see from this angle. That way, I think. We'll slot this into our Mega ST keyboard, and we'll power up. Okay, well, for some reason it seems to have bypassed the hard disk, which is a bit of a shame. But here we go. Here's my nothing. It's actually not responding at all to key presses. Let's try reset there. Ah, now it's booting from the hard disk. Okay, that's good. No, it still doesn't look like that's responding. No, the keyboard's not responding in general. No. Okay, so that's just booted up without the Smallymouse dongle attached. So worryingly, it may be related to the dongle. I'm going to see if I can connect it whilst we're powered on, which is maybe a terrible idea, but let's give that a go. This is obviously not generally regarded as a good idea, but we all did it millions of times when we were in the 90s. Okay, so I'm popping that in there. Ah! I just moved the mouse and there we go. There we go. So the programming was fine. Perhaps I just had the keyboard strained too far away and there was actually no keyboard connection. Oh dear. There's always something that will scare you, isn't there, in this game? Right, that's with the keyboard. That's with the mouse. Whoa. Yep, there we go. Definitely the mouse. Perfect. Well, I suppose it'd be rude not to have a little look at Day of the Tentacle, wouldn't it? Given I've got 4 megabytes in this machine. Okay, I may be here a little while. Okay, so I'm very happy with that, but obviously this jumper is completely redundant. I say obviously, I probably did mention it briefly. Basically, that used to control a what's the term? A mouse acceleration factor, basically. But for the ST, it's pretty much irrelevant. I discovered so. It's practically unused and is just normally always closed. So I think I'm going to remove that because it isn't serving a purpose, and we'll just put in a little horseshoe jumper so that it behaves the same as the other one. So let's just pop that off quickly. Probably should have done this when I was removing the other stuff, shouldn't I? But I have only just decided to do it. So I'm using my desoldering gun here, which is massively overkill for the task in hand, but well, why the heck not? There we go. Let's oh, perfect. That's a very delightful result. I'm not used to using that on good quality board, as in modern corrosion damaged boards. So that's a real treat to see that just plop out there. And we'll try and force this little. This is an old resistor or component leg. Might have been a capacitor, might have been an LED. There we go. We'll just force that through there. Splay those out a little bit on that side. Hold it in place, and we will we'll tack that down. Sorry for the fan hum in the background. That is the downside of the desoldering station. There we go. Okay, so there we go. We now have 2 functional Smallymouse2 devices. That, by the way, is just an experiment I added to see whether I could improve the reliability when using extension leads on the keyboard. It is quite a power-hungry little sausage, is this chip. It obviously it's driving a mouse on there as well, and if you put too many extension leads on the keyboard connector, like I tend to do with these extended DuPont cables, and these aren't the greatest quality probably, then it can brown out a little bit. So that was just a little experiment. That didn't really work. I suppose what I could do is put a sort of resistor capacitor network across that reset line. That might work, you know, give it a couple of seconds when the power comes on for things to stabilize, and then basically release reset. That might not be the world's most terrible idea, but in normal use with this tucked safely under the keyboard on a wedge ST, or tucked away there directly in the Megas tray, these work beautifully, and they do make modern mouse usage really quite smooth indeed on the STs. Much better than I had a Tom 2. I use that on the Amiga, and it's not great. I much prefer it, to be honest, and this works with USB instead of PS2, which is also a dying breed these days. So there we go. I hope that was relatively interesting to you, and if you haven't got a modern mouse solution for the ST, then do consider my Smallymouse2 repository. It does have some custom changes on the Smallymouse2 repo for the ST. Primarily, obviously, the layout is small, but it's things like open collector on the mouse buttons, so that there's not a reset when you press right and fire at the same time on the joystick, and the ST requires very, very low DPI pulses on the quadrature, which even the old 8-bit machines could handle higher rates, and it just tends to max out on the ST. So that's why I did it. Please have a look at my previous video, which I've probably already linked. Well, I linked it earlier on, didn't I? So I'll see if I can I'm not sure I can put it in twice, but I'll link it somewhere in the description down below. Do please have a look at that if you're interested. And these cost absolutely nothing to manufacture, these boards. It's just a case of getting hold of the components. So anyway, there we go. Thanks for watching, and I will see you in the next one.